Hello, and welcome to our session on IoT and digital risk. I'm Arthur Fontaine. I work at RSA in solution strategy, and I'd like to talk to you today about treating your IoT deployments as a digital risk, which it is. And I'd like to also give you some information on how you might get your infrastructure under control and how to prepare yourself for a future where your IoT deployments are as secure and de-risked as your IT deployments. So here's the obligatory slide on the market scale and scope, and you sure know for yourself every day as in your organization with the explosion of IoT devices. The stat that I like to point out to people is that in just a few short years, in 2025, there'll be over 150,000 devices being added to the IoT infrastructure every minute, every day across the globe, and that's a lot. So the issue with IoT, as with all digital risk, is that it's derived from digital transformation. And the digital transformation of your machines and devices onto your network has caused a lot of benefits, has driven a lot of benefits. Your organization is getting efficiencies in how they operate. You're dealing with your customers better. There's a lot of great things about IoT. But like any digital transformation, it brings digital risk. And the digital risk from IoT is felt most acutely in two places. First, in your SOC or your cybersecurity defense organization, and second, in your risk organization. So under the IoT categories that are baffling and challenging your SOC and your security staff are just the sheer breadth of the categories. So you have industrial IoT, industrial Internet of Things. These are the network machines that are driving your distribution networks, your factories, your oil refineries. And they're very sophisticated and complex, and they're also very mission critical. Then you've got the Internet of Medical Things, which is all sorts of sophisticated devices running different operating systems and protocols and doing many things that are critical to keeping people alive. Smart cities are emerging as an IoT infrastructure that helps people move things around cities and keep the systems running as they should so that everybody in real time is getting the services they should. And then, of course, we see especially going forward, explosion of smart homes and smart TVs and smart devices and smart coffee makers and light bulbs and everything that is really driving the proliferation of volume as much as anything else. And then if you look at your policy issues that your risk management group cares about a lot, you've got regulatory issues where you have to make sure that you stay in compliance with the regulations that affect you. They may be across jurisdictions and they may not be harmonized. You have to deal with that. Digital privacy issues, we're all concerned with that as well. We're going to have increased data collection. These devices by nature collect data. Some of that data is personal, some of that data is sensitive. So you need to lock that down and make sure that it's not violated in any way. And then you have data security issues. As your surface area is opened up with all these IP-based devices, there are new ways and new opportunities for clever criminals to get into your organization and try to take things apart. So, again, you really have two groups that are going to have to care about this, your cyber group and your risk group. Every major analyst, every person who is in this area expects that IT and IoT will converge over time. That's going to be a process. It's going to take a while. And in the meantime, these two groups are going to be doing a lot of work. So here at RSA, we've identified 8 critical digital risks that have resulted from digital transformation over the past decade or two. And of course, we have the cyber attack risk that you need to deal with. Originally, it was a smaller surface area, it was perimeter based, and now it's something that you have to protect with zero trust and other modern approaches to fighting the cyber criminals. Third-party risk is when somebody who has a contract with you does something that affects you, and there's a lot of concentration on that. Dynamic workforce risk, especially with COVID-19, and as illustrated by the fact that we're doing these sessions remotely rather than in person, as we'd all like to do. You've got people all over the world using different protocols, different networks, different devices, and locking that down is difficult. Cloud transformation is a big part of every organization's digital transformation, as things are moving willy-nilly to the cloud, and you're going to lose some visibility. You're going to lose some security that you might have had in place when you controlled all these things on premises. Data governance and privacy is a challenge, certainly in Europe with the GDPR, but increasingly with all jurisdictions that are really adopting the principle that personal data belongs to the person who is associated with it, and you need to protect that as that person would him or herself. Business resiliency, of course, with COVID-19 has been tested. As we look around, a lot of organizations have not made it through already, and a lot more aren't going to make it through to the end. It's a fact. We have to deal with it. But the one factor that is going to help one organization get through one of these events faster than another or more than another is how they've worked on their digital resiliency ahead of time. Process automation risk is another one. As we continuously optimize and automate processes and systems, there's opportunity for failure, either intentional or accidental. So that also is a digital risk that the more you kind of get modern, the more you increase your risk and need to deal with it. And lastly, compliance. Compliance never goes away. Those of us in the SIM and cybersecurity market understand that you need to be able to document what has gone on in your organization and that you have plans and programs in place to remain in compliance. So the thing about all of those digital risks is that they actually have an IoT component. So if you look at IoT digital risk impacts, you'll see that all of these existing major problems are exacerbated or have different factors that they need to deal with because of the explosion of IoT. Certainly, everything from cyber attack risk, where you have all these endpoints that could be attacked, new attack vectors, to your dynamic workforce risk, where suddenly you've got devices sharing home networks. All of the digital risks have an important IoT component, and we put a lot of thought into thinking how we can express and explain that to our customers and to the market in ways that will show that there is insight to be gained from this approach, and there are ways that you can address it. So going forward, there are a couple of important evolutions that are going to help us both get what we have out there today under control and to put us in a better posture for the future with devices that arrive out of the box more secure and plans and programs that allow you to deploy them in a more safe and secure and de-risked way. The first is edge computing. And edge computing is a term that's applied to all of IT, and there's a drive to move the processing and the logic closer to the actual applications and people who use them. Well, similarly, in IoT edge computing, there's a drive underway to put more processing power out toward the devices to assist them and let them do things that they can't do today in a kind of a siloed vertical world. We'll talk about that in a second. And that's really important for your cyber team because they're going to be looking for this architecture to help them get things under control. Going forward, the emergence and maturity of standards and frameworks from all sorts of organizations and governments is going to ensure that as time goes on, the devices, again, are going to arrive more secure out of the box, and there's going to be a lot more kind of understanding of the best practices and the strategies you want to use to get them out there in the maximum de-risked way. So those two critical evolutions are what I'm going to express as optimism, right? Where we're going to start to get this dog's breakfast of things under control, and we're going to be in a position going forward to improve our posture overall. So when you talk about IoT edge computing, it's really critical to understand, and this is really something that happens a lot in deployed systems like operational technology or industrial control systems that are out there now. These were typically purchased and deployed as projects or single solution deployments that are designed to do something specific, like keep your windmills running or give information from cars back to the manufacturers. And they're all very useful and innovative, and they've really given us a lot more capabilities than we would have had without the IoT devices or the systems that support them. The issue that some people are finding, and it is something that's increasingly coming into play, is that all of these applications are deployed as silos. And they're all customized. They don't design a lot of extra capacity for things that aren't dedicated to the activity at hand. So for example, your thermostats don't pack a lot of extra memory for you to load security software on, for example. But they do communicate with the cloud or data center service with which they're associated. Oftentimes, especially in the cloud, that data service doesn't belong to you as the deployer of the system. It belongs to a service you subscribe to, or a manufacturer or a service provider that is providing an end-to-end solution. So you introduce a third-party risk there as well. But the big problem is that these things are silos. And so whenever you want to secure or de-risk one of them, you must do it solely in the context of the application and the devices that belong to it. And so there's really, you're kind of doing it over and over again, and you're kind of locked in harder each time you kind of do something new, or the longer you stay on there. And there's really no awareness between these systems of each other. So edge computing addresses that in a pretty clever but a direct way. It places a layer in the middle between the cloud or data center, and which we call the northbound side of the equation, and the devices themselves, which you're out on the edge. We call them the southbound side of the connection. And while this looks like it's kind of in the middle in this IEEE chart, you really do deploy these things physically and logically closest to the devices that they support. So when you do that, you're able to create a layer that does things that the devices themselves and the applications in the cloud or data center can't do, which is apply real-time data processing and basic analytics locally, essentially beefing up the capabilities of the devices themselves that attach to these gateways. You can do data caching, buffering, optimization. You can reduce the amount of traffic that has to go from the devices to the cloud by filtering at the edge, where you can gain bandwidth and efficiencies. And you can also talk machine to machine. So in this way, you can have systems that were not designed to even contemplate the awareness of each other actually acting in concert. And this is a kind of a conceptual way of looking at what is in actuality a very useful way to architect your systems. You gain a whole lot of capabilities just by attaching your devices, registering your devices with these edge gateways that sit nearby. And let me take a second to show you an example of how it works. Now, we'll talk about the EdgeX Foundry, which is probably the premier open source edge platform hosted by the Linux Foundation, run by the Linux Foundation. But there are many other open or proprietary systems that operate much the same way, and in that they're a set of microservices that are loosely coupled and that are very pluggable. So you can add or swap out capabilities in one area very easily. And so in this example, which again is the EdgeX Foundry, the southbound devices sit out where they're doing all their stuff, their sensing and their switching and all their kind of monitoring of their environments, and then doing the things that they do to produce value to the organization. And they still talk to the northbound infrastructure and applications, whether in the cloud or on the data center, but they go through this gateway. And on the gateway is loaded this software architecture you see right here. And again, it's a loosely coupled microservices framework. It starts with the device services on the southbound side that attach to the devices themselves and talk all the myriad protocols that these devices were designed to talk. And this kind of is the Rosetta Stone, where you can have one system talking to many different protocols. And most of the platforms provide the major ones, but you can add additional device services by writing a connector of your own, if you will. And then on top of that, you have the core services, which give you data, command, metadata, and registry configuration capabilities. And this helps you manage the gateway itself. On top of that are supporting services like a rules engine, scheduling, alerts, and notifications that make it very programmable. You can actually add logic to the gateway that acts on the devices, kind of as it sits in the middle between the data center and the devices themselves. And then, of course, you can export the data upward, either filtered or pure, and you can provide additional services there. Importantly, you can add application services. And we provide an SDK, or all the systems provide an SDK for that, where you can customize the processing and output of the gateway to match and optimize what it's trying to do against its cloud application. And then you can add in, plug in management services, for example, a discovery service. What is on my network? What is it running? What version is it? All those discovery services can just be plugged in to the foundation. And equally, you have the ability to add security services that can actually work on the data in a passive way and view it, and then allow you to get wisdom out of all the traffic that's going through to all of the services that are being supported, and apply logic. And we'll talk about that in a second, but let's walk through what this looks like. So first of all, we have a device. It's a fan that is operating off BACnet, and it has a temperature sensor that says it's operating at 102 degrees, which is outside of its expected envelope of temperature. And it fires off an alert to its northbound system. And it goes through BACnet, it goes through the gateway's core data services, it goes to any additional services that apply, and then it sends it off to the system that needs to know that it's operating at a high temperature. So if that were the end of it, then the gateway isn't really doing anything except for passing through data. But because it has capabilities, it can do some things. So one of the services might say, hey, look, I want to run that alert through a rules engine and see what it might know. Well, the rules engine might be programmed to look at not just that device, but other devices, and send a command back that says, hey, I recognize that using a whole different protocol, this boiler here is what's generating that excess heat. And it can actually stop the machine. So this is actually a real big breakthrough, because previously that kind of coordination would have had to take place at the cloud or data center layer. And now you're putting it right out at the edge where it's useful. So the last point here is that as you can plug things in, well, you might have a security monitor agent. RSA has one called RSA IoT Security Monitor that can also take that data and take a look at it, send it off to a security cloud, analyze it using user behavior and other threat detection methods, and determine whether that was simply an environmental accident, which happens, or whether somebody has maliciously planted some code on your system that is making things run out of their temperature envelopes, right? So all of these things are pluggable, and if you don't like one company's, you can grab another. If you don't like one project, you can grab another project. Loosely coupled, highly pluggable, and it really is the future. Now, it can talk to a lot of existing products, systems and products out there, devices, and you can write plugins so that it can talk to anything on the planet, conceivably. There may be systems out there that aren't ready for the edge architecture, but increasingly as you go forward, that's where you're going to see a lot of the energy, is systems are going to support and expect this edge architecture. So let's take a look at what your risk folks are looking at. So one of the advantages of time here is that we've had some experience in the marketplace, and we understand that there are going to be some requirements for securing and de-risking your IoT systems. And a lot of the major standards bodies have taken this to heart, and they've started introducing things that are going to be very helpful. I'm not going to run through all of them here today based on time available, but I'm going to run through 3 or 4 critical ones that illustrate the improvements that you'll see going forward as both device manufacturers and organizations that deploy IoT systems gain the ability to normalize and de-risk these things. So the first one I'm going to talk about is NIST. And then NIST is the United States National Institute of Standards and Technology. And as a matter of fact, just last week, the US Congress passed a law that is going to require all US government purchasers to have certified NIST devices and systems when they purchase their IoT. So the first NIST regulation is the IoT Device Cybersecurity Capability Core Baseline, which helps manufacturers look at how to make sure that their systems arrive at the customer already secure and de-risked. And then the device manufacturers is the core part of it. The A is the baseline, but the actual framework itself is the 8259. Another one is MQTT. This is just an example of a now maturing telemetry transport that is designed for efficiency in machine-to-machine IoT connectivity. Again, so these things can talk to each other much more easily. The EdgeX Foundry we just talked about is a common open platform unifying the IoT edge. Open source, it's an Apache 2.0 open source licensing model, and it's got a community of developers and companies that contribute to it and improve it over time. Another important one is the IIC, or the Industrial Internet Consortium. They've created the Internet Security Framework, or the IISF. That's a comprehensive resource that you can read and understand to help you do your deployments. On top of that, they created the maturity model, or the IoT security maturity model, that lets you basically take a checklist approach to identify where you are in your security and where you need to go. And as a matter of fact, RSA Archer has a module that you can use to automate this if Archer is your risk management platform. Another one is the FIDO Alliance, and this is in the identity world. When this is finalized, you'll essentially have the ability to treat an IoT device like any other identity in your organization in terms of things like lifecycle management, access management, et cetera. Last couple I'm going to talk about is ISO and IEC has some global standards and frameworks. which are very mature and important, very specialized. Some of them are around edge computing itself, as well as industrial IoT. And lastly, the IETF has written essentially a book on the IoT security state of art and challenges that if you read, you'll walk away with a much better understanding of the things you need to concentrate on and take care of. So just a couple of closing comments on how you can approach this as an IoT security risk manager. Make IoT part of your risk and security plans. Treat it like any other digital risk. Make sure you engage the right functional areas and address the kudzu or the tangle of freely deployed devices that are out there now. Empower your IoT use. Don't be a blocker. This is goodness. IoT is goodness. You want your company or organization to take advantage of it. But encourage use of the IoT when appropriate, but require security and risk review, and create a playbook so folks can get started, and then you can help them get to the edge of the end of the game there. And lastly, the questions you want to ask yourself. Do we have a handle on current IoT deployments? Where do challenges exist in deployed or what we call brownfield devices? Are there siloed systems that we can integrate, or should we? Do we really know what's out there in our environment? And do we have a strategy going forward? Have we implemented an edge architecture to plug everything into? And are we able to track and prove conformance to the standards and frameworks that we elect to support? So with that, my time is up. I want to thank you very much for listening today. I want to thank the MENA ISC for the opportunity to reach out to you. And I'm in the live chat. Any questions, feel free to reach out to me. My contact information is at Arthur Fontaine on major networks. Happy to speak to you. Have a great day. Thank you.